Hello everyone, my name is Salman Salim and this presentation is titled Usable and Trustworthy Cryptographic Engineering, a mini-survey. Cryptography protects almost everything we do online, yet it remains one of the hardest parts of software to implement correctly. This talk summarizes 5 key research papers that explore how we can make cryptography both usable for developers and verifiable through automated evaluation. I'll walk through each study from IDE-based tools like CogniCrypt and Fluent Crypto to usability failures such as why can't Johnny fix vulnerabilities, and finally large-scale evaluation efforts like why crypto detectors fail and mask to show how they connect into one feedback loop for trustworthy cryptographic engineering. Even though modern libraries offer strong algorithms, cryptographic APIs remain low-level and confusing. Developers must manually choose ciphers, modes, key sizes, padding, often without security training. Studies repeatedly find that most real-world applications contain at least one misuse, such as weak keys or hard-coded secrets. The deeper issue is the usability gap. Crypto APIs were written for experts, not everyday developers. Without clear guidance or defaults, even motivated programmers make subtle mistakes that compromise security. Researchers realized that instead of expecting everyone to learn cryptography deeply, we need development tools that embed secure choices directly into their workflow. CogniCrypt from Kruger and colleagues addresses this challenge inside the Eclipse IDE. Developers describe what they need. For example, encrypting data and tool automatically generates secure Java code following established cry-SL rules. The workflow shown here converts user input into a verified cryptographic implementation using constraint solvers and XSL transformers. This automation drastically reduces cognitive load and the chance of misuse. Instead of copying code from forums, developers receive guidance as they type, ensuring encryption, key management, and communication settings meet best practices. Fluent Crypto brings similar usability principles to Node.js. Rather than configuring algorithms and padding manually, developers can chain intuitive commands such as encrypt with key dot using AES. The study compared Fluent Crypto to default Node.js API. Participants completed cryptographic tasks in far less time and rated them as much easier. The figure highlights both metrics, time savings and reduced difficulty improved. These improvements prove that API design doesn't just help productivity, it directly enhances security by preventing misconfiguration. Even with analysis tools, developers still struggle to act on security findings. The SOUPS 2020 paper, Why Can't Johnny Fix Vulnerabilities, evaluated 4 popular static analyzers, including RIPs and find security bugs. The screenshot you see here is for RIPs, showing how its visualization becomes unreadable as the project grows. Developers reported frustration with overwhelming warnings, confusing messages, and too many false positives. Many eventually disabled and uninstalled the tools entirely. The takeaway is that poor usability directly reduces security outcomes. If a tool's interface prevents comprehension, vulnerabilities remain unfixed. Improving detection accuracy alone is not enough. Usability must be treated as a core security property. After identifying usability gaps, researchers turned to the reliability of the detectors themselves. Why Crypto Detectors Fail by IEEE 2022 mapped 128 real-world crypto misuses grouped into categories like weak keys, insecure cipher modes, and poor randomness. The taxonomy you see here summarizes those misuse types. Follow-up work by Mask 2023 built an automated mutation testing framework. It injects controlled crypto errors into code, runs multiple detectors, and measures which issues each tool catches or misses. Together, these efforts transform detector evaluation from ad hoc testing into repeatable data-driven benchmark, revealing serious blind spots and setting stage for continuous improvement. In conclusion, usable and trustworthy cryptography depends equally on 2 pillars: human-centered design and scientific evaluation. Usability ensures that developers can easily and correctly apply cryptographic principles. Evaluation guarantees that detection and prevention tools are reliable and continuously validated. The intersection of these 2 areas is where genuine trust is built. Future directions include integrating evaluation frameworks like Mask directly into the IDEs so that developers receive live context-aware feedback. Ultimately, True security isn't just about strong algorithms, it's about enabling every developer to use confidently and correctly. These are the references used. That is it for my presentation. Thank you.